So in part one, we looked at the definition of an ellipse, how to identify the center from the equation. Now we're going to look at the other pieces we talked about, which are the foci, the vertices for the major axis, and the vertices for the minor axis. Sorry for my coughing. Oh, sorry, I was just trying to scroll down on that screen, make sure it's all visible. Okay, so the center we talked about in part one, that's just what's being subtracted from the x value and the y value. That's the same as it is for a circle. Okay, now for the foci. For the equation in the form I have it written here, where the larger denominator, that's always the a, the larger denominator is under the x value. The foci is, there are two of them. The first one would be h plus c, and then k, and then h minus c, and then k. So one important thing to note here is that for all of the points, the center is really the center of all of them. The center is what helps form all of these points. So for the foci, when we're in this form, where the larger value is under the x value, we will add and subtract a number to the x portion, the h in the center, to get the foci. And then for the major axis, we will get the vertices by adding and subtracting a point to the x value again. And for the minor axis, we'll add and subtract a value to the y value. So notice, their starting point for all of them is the center. So even if it doesn't explicitly ask you for the center, you'll want to find that first, because that's the way you'll figure out what the other points are. Okay, now you look at the vertices for the axes. The a and the b are pretty straightforward. You just find them by taking the square root of whatever the denominator is. So if the denominator was 16, then our a would be 4. Or if it was 36, it would be 6. Things like that. Now, the c is new. That's why I gave this point right here. To find c, you'll have to use this equation. C squared is equal to a squared minus b squared. So I'm going to pause here just a moment to make sure you have time to write all this down, but feel free to pause the video if you need to get all this covered before we do some examples. But please note, what I'm writing down here is only the ones that work when it is the x value, or the term with x in it, has the larger denominator. We'll look at it when it's the y value instead that has the larger denominator, but right now we're just focusing on this. Okay, so this is asking us to find the foci and the vertices. So it says the vertices, that's talking about all 4 of them. There's 2 for the major axis and 2 for the minor axis. Here we go. They don't ask for the center, but like I talked about, the center is what's going to be the starting point for all of these. So we're going to start by finding the center. So a -3 is being subtracted from x, and a 4 is being subtracted from y. So let's start with the foci. Remember, the foci, we'll have to add and subtract c to the x value. So let's start by finding c. C squared is equal to a squared minus b squared. So c squared is equal to 100. I know that's the a squared because it's the bigger one. The bigger one is always a, minus 64. So c squared is equal to 36. C is equal to 6. So to find my foci, I need to add and subtract c to the x value in my center. So I used c squared equals a squared minus b squared to find the value of c. Now notice you'll always be putting the bigger number first, so you should never end up with negative numbers in imaginary stuff. That should never happen, because it's always the bigger number minus the smaller number. And then we need to add and subtract that number to the center. So the order doesn't matter. You can subtract first or add first, doesn't matter. I'll just subtract first. So negative 3 minus 6 gives me negative 9. Negative 3 plus 6 gives me positive 3. So again, to find the foci, I'm just adding and subtracting a number to the x value of the center. So I subtracted 6 to get that one, and I added 6 to get that one. So that's how we get the foci. Now for the major axis, the vertices involved with a major axis, I need to use A. So if you look back at the equation, or the way to find it, we're going to add and subtract A. So it's similar to what we do with the foci. We're adding to the x value. The only difference is we need to add A to it instead of C. So to get A, we look at the denominator. This is A squared. So if A squared is equal to 100, then A is equal to 10. So for the major axis vertices, I will need to subtract 10 from the x value in the center. So I'll get negative 13, 4. Again, I'm just doing negative 3 minus the 10 minus the a value, which was 10. And then I'm also going to add the 10. So negative 3 plus 10 gives me 7. Now, for the minor axis, I'm switching over. I'm going to add and subtract to the y value. I'm going to use b. That's the smaller denominator. It comes from the smaller denominator, I should say. So this is b squared because it's the smaller one. So if b squared is 64, b is equal to 8. So I need to add and subtract 8 from my y value. So I go back to the center. That is my starting point every time. So I'll do negative 3. That doesn't change. And then I do 4 minus 8 because I subtract the b. So 4 minus 8 is negative 4. And then 4 plus 8 is 12. So now I have all the important parts that were asked for. I have the two foci. I have the major axis vertices and the minor axis vertices. Now we're doing another example, but truthfully, if this felt like too much all at once, I'd recommend you back up and just watch this example again. The process is the same each time, so just make sure you understand the process of finding each one. Okay, so now we're switching gears though and looking at the ones that are more vertical, where the bigger denominator is with the y term. So the difference here is that the term with the y has the bigger denominator. So the process is actually exactly the same as it was for the other, except we're switching whether we're adding and subtracting to the x value or the y value. In the other one, to get the foci, we add and subtracted c to the h. But this time we're oriented the opposite way, so we're adding and subtracting the c from the k. And the major axis vertices and the minor axis vertices is the same idea. The major still uses the a, but this time it goes with the y. The minor still goes with b, but it gets added to the x value, the h. Now, if you remember the definitions, that might help you figure out why we do the foci to the x or the y, because the major axis is the one that has the large denominator, or related to that one, and the major axis is the one that passes through the foci. So here, y has the bigger denominator, So it's y that helps us find the foci. Previously, the x had the bigger denominator, so it was the x's that helped us find the foci. And as far as the major and the minor, I think you can just look at the fact that, okay, major means bigger, a is bigger. This time, a is paired up with the y value, so a gets added to the y value. Minor means smaller, b is the smaller number, it's paired up with the x, so this time b will be added and subtracted to the x value. And the c squared equation is exactly the same as before. You just do the bigger one minus the smaller one. You do a squared minus b squared equals c squared. So I'll pause a moment to make sure you can write all that down. And just one more reminder, the issue is not which term is written first. We're adding the x and the y terms, so it doesn't matter what order we write them in. What matters is which one has the bigger denominator. So our first example was when x had the bigger denominator. For this one, we're looking at when the y has the bigger denominator. Okay. So find the foci and the vertices. So just like before, we need to start by finding the center. And like I said before, maybe another video, make sure you're putting them in the right order. Yes, I know y is written first. We don't magically put the y in front of the ordered pair though. So just like normal, an ordered pair is x first, y second. So when I'm doing the center, I look and say, okay, x plus 4, I'm subtracting a negative 4. So my center is negative 4, and I'm subtracting 3, so I get that as my center. Again, they didn't ask for that, but the only way I'm going to find the foci and the vertices is by starting with the center. So please, I'm trying to warn you as best I can. A mistake I see very often, or have in the past, with these is people just flip these around. They say, oh, well, the 3 from here and the negative 4 from here, so my center is 3, negative 4. But it's not. Always x value first, so negative 4, 3. So make sure you're careful about that. Okay, to find the foci, I need to find c. And I know that c squared is equal to a squared minus b squared, which for this equation, the a squared is always the bigger one, so it's 25 minus 9. C squared is equal to 16. C is equal to 4. And just so you know, if it doesn't come out a whole number, just leave it as a square root. So if it had been 17, then I would just want you to write c is equal to the square root of 17 and not convert over to decimals. So you would have a foci looking something like 3 plus the square root of 17, 3 minus the square root of 17, and just leave it like that. That's better in math because it's actually more exact to write it that way. Okay, now note, back here, since the bigger denominator is with the y, we're going to be adding and subtracting the c from the y value in the center. So to get the foci, I'm going to subtract 4 from the 3, so I'll do negative 4, 3 minus 4 is negative 1, and then negative 4, 3 plus 4 is 7. And then we need to find the vertices. So for the major axis vertices, we need to find the a. Remember, that's going with the bigger denominator, so 25 is equal to a squared, meaning a is equal to 5. And if you go back and look at your terms or your equations, for this one, the major axis vertices, since the bigger denominator is paired up with the y, we're going to add and subtract that number to the y value. So this is going here. Now our a is 5, so I'm sorry, I underlined the wrong thing. Let me go back, make sure I emphasize this correctly. So for the major axis vertices, since the bigger term the bigger denominator, is with the y, we will add and subtract it to the y. So let's see if I can do this correctly this time. We will connect the a here with the y value. So we'll do -4, and then we'll do 3 minus 5 is -2, and then -4, 3 plus 5 is 8. For the minor axis vertices, we'll use b. That's the smaller of the two denominators. This is b squared, so b is equal to 3. And you can see it's paired up with the x term this time. So we'll add and subtract the 3 to the x term of the center. So -4 minus 3 is -7. -4 plus 3 is -1. So notice the foci and the major axis have numbers added to the same piece. In this one, we are adding and subtracting numbers to the y value for both the foci and the major axis. It's always going to be that way, that those are adding to the same term, either both to the x like they were in the first example, or both to the y like it is in this example. Whatever has the bigger denominator, that's what's going to have something added to it to get the foci and the major axis. Then the minor axis is the one that will be different from the two. Again, if you need to, just rewind and look at these two examples again, because this process is the same every time. You just have to make sure you look carefully at the equations and are paying attention to which one has the bigger denominator. Last thing for ellipses. This asks us to find the foci and the vertices, but they don't give it to us in the standard form. Eesh. Whew, alright, so we have to find the standard form. Well, if you haven't watched the circle videos, then I would recommend you go back and look at those. It talks about how to use completing the square to put things in standard form. We're going to do something very similar here. So, first, we need to make sure, like we did in that video, or like we did with circles, I should say, you need to make sure the constant is by itself on the right-hand side, which it is. We also need to reorder things so the x's are together and the y's are together. Okay, now the coefficients in front of the x squared and y squared are not 1, but unlike in circles, the two coefficients are not the same. We have a 4 in front of the x squared and a 9 in front of the y squared. So this one is a little bit trickier, because we can't just divide a number and fix both of those. So we divide by 9, that fixes y squared, but leaves us a fraction of 4/9 in front of x squared. If we divide by 4, that fixes the x squared, but doesn't fix the y squared. So we're actually not going to divide in this case to fix that. Instead, what we're going to do is factor it out just among each individual set. Here's what I mean. Let's just focus first on the x's. We cannot complete the square with that 4 out front, so I'm going to factor the 4 out like this. Now I'm going to focus on completing the square just inside the parentheses. So I take this number, -10, cut it in half, that's -5. I square it, that's 25. So I'll add 25. But I have to do it to both sides, and here's the weird part. I'm not just adding 25 to this side. I'm adding 4 times 25 to this side. Notice, inside the parentheses, I am just adding 25. But those parentheses are being multiplied by 4. So in total, I'm really adding 100 to both sides. 4 times 25. So over here, I need to add 4 times 25. You can just write it as 100 if you want. I'm just trying to make sure it's clear where that's coming from. So when I'm adding the 25 inside the parentheses, for the whole equation, I'm really adding 4 times 25. So that is what will have to be added over to the right-hand side. Then for the y's, we'll do the same process. We'll factor the 9 out first. And then I will take this number, cut it in half, that's 2, square it, that's 4. So inside the parentheses, I'll be adding a 4. But to the whole equation, I'm really adding 9 times 4. So I'll have to do that over to this side. So I end up with 4 times x squared minus 10x plus 25 plus 9 times y squared plus 4y plus 4. And when you add all this together on the right hand side, you should just get 36. Whew, I know, lots of fun. You're right. Now I need to factor this. Same as before, it always ends up just being half of this middle term's coefficient, so it'll be x minus 5 squared and 9y plus 2 squared. And we're not quite done, because to be an ellipse, if you look back at all the standard forms, it's always equal to a 1. So I need to divide everything by 36 so that I can have the equation equal to a 1 like it's supposed to be. And conveniently, those cancel out very nicely. 4 over 36 reduces to 1 over 9. Nine over 36 reduces to 1 over 4. And 36 over 36 is 1. Sadly, we haven't actually answered the question yet, because they want us to find the foci and the vertices. We can finally do that, though, now that we have the standard form of the equation. So I know I may have gone a little too fast here at the end, so I'm going to pause just a moment, try to help you catch up. Then we'll look at finding the foci and the vertices. Okay, let's start with the center. X value first, so we're subtracting a 5. Y value second, we're subtracting a negative 2. So I have the center. Now I'll do the foci. To find the foci, I need to use c squared equals a squared minus b squared. So c squared is equal to 9 minus 4. So remember, this is a squared, the bigger denominator. 4 is b squared, the smaller denominator. So I get c squared is equal to 5. So c is equal to the square root of 5. So I referenced this earlier, that you should just leave it as the square root of 5. Don't convert it to a decimal. Don't do it. Since x has the bigger denominator, I will need to add and subtract the c to the x value in the center. You can go back and look at your equations. Since x is the term that has the bigger denominator, I'll add and subtract the c to the x value to get the foci. So I'll do 5 minus the square root of 5, negative 2. So I'm just subtracting the square root of 5 from that original 5, and then 5 plus the square root of 5, negative 2. Okay, now for the major axis vertices, we'll need to use this right here. This is a squared. So 9 is a squared, so that makes a equal to 3. And you can see it's paired up with the x, so I'll add and subtract that to the x value of the center. So the major axis vertices, I will subtract 3 from that 5, and I will do 5 plus 3 and get my two major axis vertices. Do my minor axis vertices. we'll use this. This is b squared, so b is equal to 2, and it's paired with the y, so we'll add and subtract 2 to the y value of the center. Negative 2 minus 2 is negative 4, negative 2 plus 2 is 0. And I think that is enough with ellipses.